Lesson 2.5, solving equations with absolute value. Essential question. What is different about solving an equation with absolute value bars? So this lesson will actually have absolute value and an equal sign because we're going to be dealing with equations. So something unique is going to happen when we start solving these problems. Okay, so first of all, let's look at these two questions. Let's look at the top one first. If the absolute value of x equals 7, what could x be equal to? So what two numbers have an absolute value of 7? Well, we know that 7 has an absolute value of 7, so that's one of the answers. What other number has an absolute value of 7? Well, that's negative 7, because remember, distance can't be negative. So negative 7 is also 7 units away from 0. So 7 and negative 7 are my two x values that equal 7. All right. If x plus 1 equals 5, what could x be equal to? So I have to ask myself, what number plus 1 equals 5? Well, I know that 4 plus 1 equals 5, because 5 equals 5. So that's one of my possibilities. Now I've got to, oops, not 4, or not 5, 4. I've got to figure out what the other one would be. So what other number plus 1 equals 5? There is another possibility. So I'll let you think about that for a second. Well, I know that if both 7 and negative 7 have an absolute value of 7, 5 and negative 5 also both have an absolute value of 5. So what number plus 1 is negative 5? Negative 6. Because negative 6 plus 1 is negative 5. The absolute value of negative 5 is 5. And 4 plus 1 is 5. The absolute value of 5 is 5. So notice how we're ending up with two solutions for these problems. We're not ending up with just one x value, that's our answer. We're ending up with two x values for our answer. All right, let's solve and graph. So keeping in mind that we're always going to be ending up with two answers, remember that going into this problem. You'll notice that below my problem, I have case 1 and case 2 written. This is what is going to help us get our two answers. Those ones we could fairly do easily in our head, but this is a more complicated equation. So we don't want to sit and guess and check how are we going to get 20 and how are we going to get negative 20. That's going to take too long. Here is how you solve it. Case 1, we're going to write the exact same equation, except I'm going to get rid of the absolute value bars. So the only difference between my original and this one is that I got rid of the absolute value bars. Let's go ahead and solve this. So add 8 on both sides. For my number line. X equals 7. This is one of our answers. How do we get the other one? This one is a little bit trickier of the two to remember. The 4x minus 8 is going to stay the same, but the way we get our other answer is by making 20 negative. So instead of positive 20, we write negative 20. So I want you to make a note in your notes. Make case 2 negative, meaning the answer negative. Nothing changes with the 4x minus 8. It's just the 20 becomes negative. Let's go ahead and solve that. Negative 20 plus 8 is negative 12. So x equals negative 3. So now we're going to graph both of these solutions. So I'll just say in the middle of my number line is about here. So I've got to go 1, 2, 3, 4, 5, 6, 7. 7 is one of my solutions, so I'll put a dot there. -1, -2, -3. I'll put a dot right there. So my two solutions are 7 and -3. Let's go back and check that so we can see how that works. Well, let's take 7 first. 4 times 7 is 28. 28 minus 8 is 20. Yep, that works. Then we have 4 times -3 minus 8. 4 times -3 is -12. -12 and -8 make -20, which we know the absolute value of -20 is 20. So that's why those two answers work. If I plug 7 in, I'd get a positive 20. If I plug -3 in, I'd get the -20. All right, let's try another one. Got our absolute value equation. Anytime we see the equal sign, that's when we know we immediately need to go to case 1 and case 2. Case 1 is going to stay exactly the same. Nothing changes except for getting rid of the absolute value bars. Add 1 to both sides. So we have t equals 4 as one of our solutions. Case 2, think for a second, what do we need to do? We need to make our answer negative. So 3t minus 1 equals -11. -11 plus 1 makes -10. So that answer is not going to come out perfectly, but we can just leave it as -10 over 3. So now if I go ahead and graph that on a number line, we've got a positive 4, and 10 over 3 would be a -3 point something, so we'll just say right here. So there are our two solutions. All right, this time we've got 6y minus 7 equals -1. Now I want you to look at this equation because there's something different about it than the first two. You need to ask yourself, can the absolute value of something, so the absolute value of this is -1. Can you ever have a negative absolute value? No. If the negative was out in front, then you could, but this one doesn't have the negative out in front. It just has everything in the entire 6y minus 7 is inside the absolute value bars, and it's saying if I take the absolute value of that, I'm going to get -1. Nope, you can't. So all you have to write is no solution. So be careful. If you are starting your case 1 and case 2 and something seems a little bit weird, stop yourself. You don't want to make case 2 a positive one. You're not doing the problem right. You can't have an absolute value that makes a negative. All right. So now we are going to do a click and drag for 2 solutions or no solutions. Let's do the no solutions first, since we just did that on that last problem. Let's go back there for a second, and I'll make sure I write no solution here, so that makes sense. So what happened was, if the answer is negative, there's no solution. You can't have a negative absolute value. So let's look for where we see a negative solution. -10, can't have that. No numbers can make an absolute value negative. That wouldn't work. This one. And this one. So all of ours with positive solutions, +3, +1, +5, positive 14, they all work. Negative 1, nope. Negative 8, negative 10, negative 11. Those are all no solution. Summary.